Hello and welcome. In this video, we're going to program example number 2. And in this example, we have a problem that there is one switch. There is one off switch. It's not push button, or it is push on, push off type of switch. It's a switch like normally in house you see is light on off switch, that kind of function, but it's more of like you have to push or pull to turn on or and off in the field. Anyway, the function is on off switch. So that switch you can turn on and remain on until you turn back that switch to off position. So this kind of switch it is. Now using this switch, the PLC will do the reading of the switch status, whether the switch is in on position or off position. And then the ladder will do two functions. It will start a timer for 30 seconds, and during this 30 seconds, when the 30-second timer is running, one output will be turned on. And then immediately after 30 seconds, another timer will start. That is for 10-second timer. Now, when this 30-second expired for the first timer, the output 1 will turn off. And then another output number 2 will be turned on as long as the second timer, that is for 10 seconds, is running. So during 10 seconds, the output 2 will be turned on, but output 1 is off right now. So when this 10-second timer expires, immediately after that, it goes back to the beginning. It starts the 30-second timer again, and also the output 1 turned on, and then output 2 is turned off during 30-second timer is running. So, and then this process will continue as long as the switch 1 is on. This is our example. So here is the our documentation for that problem statement. You can read it. This section is starting switch 1 is to start a process. Process is to run for 30 seconds, stop for 10 seconds, then repeat as long as switch 1 remains closed. This is the first section of the problem. It is not telling anything about the output 2 that it is adding in the latter part of the problem. And then opening the switch at any time will reset all the timer and de-energize all the output. Output 1 is to be energized during 30-second run period, and output 2 is to be energized during 10-second period. So now if you read this in detail, you will have to assume something, that output 2 is to be energized during 10-second stop period. It is talking about the second timer, that's 10-second timer. Now this is half information. It is energized, but when it is to be de-energized, nowhere it is mentioned. But we assume, for that we have to assume that output 2 shall be turned off during 30-second period. That is the first timer. When the first timer is running, we assume that output 2 shall be turned off. So that's how actually we make assumption when doing the planning, designing the documentation, so that we can bring up this assumption to the client and customer and discuss what shall be the that 30-second period status. And the things here it is that the information should be complete. We know it is assumed that it seems like right, but we want that in documentation. So here is the thing, the number of tags we have listed. Switch 1, that is normally open type switch, and then 2 output is required and 2 timers are also required. So this is not input or output, it is actually a function of PLC that we can call this timer, and it has a built-in instruction that will calculate the timing. So let's start the programming part. If you follow along with my previous video, example 1, we have covered some of the technicalities and how we solve and design the ladder logic in PLC uh, inside OV1, how we read the input and then we utilize the data block bits, the saved bits, instead of using the direct digital input. And then we write the output into the module at the end of the OB1. Similarly, how we can use the FC function in a PLC project, that also I have discussed in example 1. Same technique we will be using here. We will be using FC in our problem solving. Here is our PLC 3 that I'm using this one, and I have a OB1, and inside OB1 I have called FC2, that is for this example 2. If I double click, this will be opened. Now in the beginning, the network 1, I have uh, reading for the reading the switch status and saving into data block, that all DI is the data block I have used to save this digital input status. And this is this one, this is boolean type. And the last is the output. So we have two output 1 and output 2, that is coming from all DO. As all DO, output 1 and output 2 boolean type are then transferred into module output, that is Q0.3 and Q0.4. And this is okay, so this is data block bit. Now the remaining ladder logic, let me just show you the module just for clarity. We are using this module. This is digital input module, 32 channel and 32 channel output module. So only one switch shall be connected to this digital input, and two output will be going towards our process from this module. And inside the ladder, this PLC, we are executing the writing the ladder logic. Okay, so let's go to the programming part. Now this switch status is transferred to here, right? So now this becomes our switch in the ladder logic. So we are using here, and when we turn on, we are turning on the timer, 30-second timer. And remember, we have this function to uh, tell that we need to restart the timer when the timer 2 is done. So when timer 2 is not done, that is this sign, that is like inverted sign. In Siemens, we have a timer that is based on IEC standard. Let me show you how I have created this timer in data block. We are using one data block. I have created the data block from here. Let's just follow me. you open new block, add new block, and then select data block and give the name. I have given the timer as a data block name and then press OK. So that will create this data block empty, and you can add as many as you want. And then I have called this data type IEC timer. IEC timer has this many number of parameters. PT is the preset time, that how many seconds or minutes or hours we are going to run the timer. Normally IEC timer is the on delay timer. And then ET is the elapsed time, the expired time, how much time is counted. So elapsed time, that's the past time. In is the enable input. By giving positive pulse into this signal, the timer will start actually. And the Q is the output of this timer. When the 30-second timer, the PT is expired, that when the it is actually equal to PT, then this will turn on. So it's like timer value is over, so this will turn on, and similarly the same structure is used for timer. Now we are calling this timer here timer 1 to run. When this timer starts for 30 seconds, in parallel we are using to turn on the output. As I told you, when the timer for 30 seconds is running, we are turning on the output 1. So now the Q timer.Q bit is actually off when the timer is running. So we are using the inverted bit. So inverted we use like this. This is normally close. So normally close means when the timer is not on, this bit is off. So if we use like this, it becomes actually true. So this is like a status 1. If Q is 0, if we use this signal, it becomes 1. So now the output is also not running at this time. We have just switched on the timer. Output is not running, our timer is still running. Then we turn on the output. Now we go into the next step. When the timer is done, that is 30 seconds is over, then Q bit, the timer.Q bit will will be enabled, and immediately we have used another timer for that. So when this is enabled, we start another timer for 10 seconds, that is timer 2. But when timer 2 is running, timer 2.Q bit is off, so we use this again, this instruction to turn on output 2, and that's how we have actually restarted the whole cycle using this timer 2.Q bit, because after 10 seconds this timer 2.Q bit will be turned on. And as you can follow me, when we turn on the switch, this 30-second timer is expired, but its Q bit will be remain on. We have used here, and to turn off and reset the timer, we have to cut off the supply from here, or you can say to cut off the status line. That's why we use the reverse of this Q output. Timer underscore 2.Q, when timer underscore 2.Q be turned on, we use the inverted instruction like this. So this will cut off the line to timer 1, and then it will restart. So once this goes off, it like resets the timer. Immediately it will also reset the timer underscore 1.qubit, and so the timer 2 instruction as well. So whole thing will be restarted again from the beginning. So timer 1 will restart from 0 again, and the cycle will continue. If you want to read more about the timer, you can press F1 like this, and help file will be opened, and you can read more details about the timer. So when the timer in is available, pulse the switch is available, your timer, that is PT, is 30 seconds. We have after 30 seconds it will remain on as long as the switch is on. So here we have actually a interlock, the timer interlock to the timer 1, timer 2 interlock to the timer 1, because it is preventing timer 1 from remain on, the output remain on, that is preventing, because after timer 2 is done, the done bit is used here to restart or reset the timer 1. Now if you want to simulate this, you can download it. Sorry. Now we have downloaded, I have the simulator opened here, it's running, and I have a watch table opened here. Okay, you see I have a switch open already, it's already on. I need to restart this. I turn off, everything goes off as per our problem statement. Now I restart this one, and you see one output turn on immediately because the 30-second timer started. As long as 30-second timer is running, the timer 2 is stopped and output 2 also off. So now just focus, now it's now 23 seconds, 4, 25, 26, 27, 28, 29, 30. You see now output 1 is off and output 2 is running, and timer 2 is running. So timer 2, 10 seconds is running, and 10 seconds is done. Now it goes back to output 1 and timer 1. So this will continue as long as our switch 1 is running. We can actually create variable for changing the timer. Instead of 30 seconds or 10 seconds, we can add some data block variable parameter, and you can name that data block like uh, variable data block or properties data block or something like that, and then that you can change in your ladder logic here. Instead of giving 30-second hard coded, in programming language we call this, giving direct value to any instruction is called hard coding. Instead of hard coding timers value like this, we can actually give variable here, and we can select the data block and then the variable name. In that way we can change the variable value from here. From here we can give value something like this. Timer value we always start from T, then something like this, and then after that we press this button modify all, or even you can right click and do modify now. That way the timer will be changed as per our new value, and that will be additional extra practice part of the problem. Example 2 for this moment. uh, I think this is enough for example 2. Hope that helps, and thank you for watching.